Hi, Coach Travis here, and I've got another problem for you about how the derivative shapes the graph of a function. All right, so what is the problem here? So we're given the graph of some function f of x. So this curvy thing here, this is the graph of f of x. And they're asking me to identify where the derivative is negative. So where is the derivative less than 0? All right, so this is actually, if you know what you're doing, problems like this are pretty straightforward. So you might say, yeah, how am I supposed to do this? They gave me the graph of f, not the graph of f prime. So I somehow have to exploit the relationship between f and f prime in order to answer the question. And so the key fact that I'm going to use here is this one right here. It's how the first derivative shapes the graph. So it says that when the derivative is negative, then the graph of the function is decreasing. And when the derivative is positive, then the graph of the original function is increasing. And the reverse of these statements is also true. So this page doesn't say it, but the converse is also true. That is, if the original function is decreasing, then the derivative must be negative. And likewise, if the original function is increasing, then the derivative has to be positive. So these implications go both ways. So all right, so back to this picture. So in order to answer the question, where is the derivative negative, that's the same. So the idea is this question is the same. Let me get a different color. This condition is the same as asking when is the original function, when is f of x decreasing? Because the original function is going to be decreasing exactly when the derivative is negative. So all I have to do is look at this picture and look for, okay, where is the function decreasing and where is the function increasing? So all right, so let's see. So I'm going to mark a couple of points on the function. Those are the critical points, the minimums and maximums. And this one looks like it's at x is -3. And this one looks like it's at x is equal to -1. And so, all right, so it looks like the answer is that the blue function is decreasing as whenever x is less than -3. Because if I'm on this region here, the function is decreasing. The function's going down, the y-coordinate is going down as the x-coordinate goes up. So I would say that we're decreasing from -infinity to -3. So I'm writing my answer in interval notation. And then now the blue function is increasing in between -3 and -1. So I don't want that. But then once x gets bigger than -1, then we're decreasing again. So -1 to infinity. So I'm assuming that there are little arrows at the end of this function so that it continues going on in that direction forever. So that would be my answer to this question. The original question was when is the derivative negative? And the answer is, well, the derivative will be negative exactly when the original function is decreasing and you just look at the picture to figure out where the original function is decreasing. The original function is decreasing for all x values less than -3, and the function is also decreasing for all x values greater than -1.